Okay, our lesson today will be piecewise function. Piecewise function, we can see them in advanced functions or in calculus. So they're same, but in calculus we do them in detail. So let's see a first piecewise function we have. A is fx, x plus 2 for x less than or equal to minus 1, and then minus x plus 2 for x greater than minus 1. As its name, piecewise, means it has different equations here, different functions on the right side. So y can be equal to x plus 2 or y can be equal to minus x plus 2 depending on the domain. So if we say now from this piecewise function, let's say we say find f of 4. The first thing we say is 4. Which part of the domain is 4? Is that x less than or equal to minus 1 or is that x greater than minus 1? So 4 is found in the second one. So I substitute 4 on the second equation. So it is minus 4 plus 2, which is negative 2. If I want to find f of minus 5, I say minus 5 is in the first equation because x is less than or equal to minus 1. So I substitute minus 5 on the first one, which is minus 5 plus 2 equal to minus 3. So let's see the graphs of this one. That means we have two pieces of graphs. So x, this is fx. The domain is x less than or equal to minus 1. So let's see the boundary for the first one. If x equal to minus 1, minus 1 plus 2 is 1. Therefore, if x is minus 1, y is 1. Is that inclusive? Yes, because it is less than or equal to. Okay. Then, since this is less than minus 1, for sure my graph will be this side because x is less than minus 1. So I take any number less than minus 1. Let's take the intercept. If x is negative 2, then this will be 0. Therefore, this will be the first line. The second line, my domain is greater than minus 1. So I substitute minus 1. So minus 1 minus minus 1 is 1. 1 plus 2 is 3. So if x is minus 1, this is 3. And this is not inclusive because it's greater than. So since it's greater than minus 1, I take x greater than minus 1. So if, let's say, the intercept, if x is 2, this will be 0. And we know the graph goes this side because it's a negative slope. So it will be starting from here. This will be, let's say this is 2. Okay, so this is my second graph. As we see here, at x minus 1, there is a jump here. As there is a jump here, so we have two different completely graphs. This is the first piecewise function. So let's take another one. B. Okay, let's take gx is equal to 2x minus 1. Okay, 2x plus 1 is when x greater than or equal to 1, and it is x squared when x is less than 1. Okay, let's see the graphs now. This is x, this is gx. The first graph is a linear, so y-intercept is 1. If x is 1, then 2 times 1 is 2 plus 1 is 3. If x is 1, my starting point will be 3. So it's inclusive, so this is 1, 3. X is greater than 1, therefore it should go this way here. Since the slope is positive here, the intercept is here, so I take any number more than 1. Any number I can take, so more than 1, like if x is 3 or 2, 2 times 2 is 4, plus 1 is 5. So this is 2, this is my graph. Then the second graph is x squared, which is a parabola, which is less than 1. If x is 1, y is 1. So it's 1, 1. It's not inclusive. It's x less than 1. We know the parabola x squared passes through 0, 0. So my graph will be starting from here, but less than that. So it will be here. This will be my graph, my parabola. Starting from here, it will not go this side here. So these are piecewise graphs.